Hello everyone, myself Deepa Singh, working as Assistant Professor in Gandhian School of Pharmacy, SGVU. Today we discuss about a capsule. In previous lecture, we already covered different types of a capsule material or excipient that is used for manufacturing of a capsule, including gelatin, different types of gelatin and how we manufacture these gelatin and different size and shapes of the capsule and the classification and how we manufacture that hard gelatin capsule cell and the parts of that particular capsule cell and different excipients and manufacturing process of this capsule cell. There's a different steps we already covered in previous lecture, including dipping, stepping, and drying, all these steps for hard gelatin cell capsule manufacturing. And today we discuss about capsule filling, finishing, and a special technique of a formulation of a hard gelatin capsule. Means we covered in this lecture, we continue previous lecture of hard gelatin capsule topic. In this, we see the filling of that particular hard gelatin capsule and how the filling and finishing just takes place and some another special technique for manufacturing and formulation of this hard gelatin capsule. So in this lecture, we already we covered different parameter of hard gelatin capsule and the introduction part and types and manufacturing of cells we already covered in previous lecture. This is the topic of industrial pharmacy, one subject of semester. Before starting this topic, we should know about basic object or learning objects. In this brief introduction about the filling of hard gelatin capsule, means how you fill these hard gelatin capsule or how the filling takes place for hard gelatin capsule and shell of hard gelatin, the body and cap part, and how you close this finishing and a special technique of formulation of a hard gelatin capsule. And different techniques, their classification and procedure for this hard gelatin capsule formulation, or all these things covered in this lecture. So in this lecture, first is filling of a hard gelatin capsule cell. In previous lecture, we covered that these hard gelatin capsule shell have a cylindrical part and it have a two part. One is cap and second is body, and the cap part is fit to this body part and we seal the sample in the body part and then close the hard gelatin capsule shell. So in this, how you fill this, and this is the punch method used for filling of this hard gelatin capsule. In this, placing the powder on the paper. Means you use the powder. If your formulation, then you place a required specified amount of the powder onto the paper, and after this forming the powder mix into the cake. With the help of this powder, you form the cake or mix of the cake, and punching the empty capsule body into the powder cake. Then say just put this powder, formulation powder, the drug capsule punching with this empty capsule body into this body of powder cake. Means first you take the powder drug into the paper and form the cake, and after forming this cake, you add this to capsule cell body part with the help of punching or punch method, and then close this cap and body part. This is regarding filling of hard capsule with the help of punch method. And next is filling hard capsule shell by pouring method. Second method is pouring. First method is punch method, and second is pouring method. In this name itself, see that you pour your formulation in the capsule body. And the pouring suitable for filling a small number of a capsule in the pharmacy. And so if you are preparing a capsule in a lab scale or a small number of capsule filling is required, then you can use this pouring method. Or if you are require capsule in a pharmacy or hospital pharmacy, or if this is quantity is very small, then can you easily pour this type of capsule or fill this type of a capsule with the help of this pouring method. Next is suitable for granule material also, means instead of a powder, you can also use granules for this capsule or hard gelatin capsule. By the help of this pouring method, both powder as well as granules are used for this. And in this filling hard capsule shell, hand operated capsule filling machine. It's a machine, or you can say that an instrument or hand operated machine, which is used for filling of a capsule and lab scale or very small scale. And with the help of this plate or this machine, you easily fit or fill your capsule. Consists of a couple of a plate, contain number of a plates or different plates, and this is the shell where you put your capsule in the strip and fill your capsule according to different methods or hand operated method, and then you close by the help of a cap. This is the simple method. And in this next is filling of hard capsule shell. Means how you fill this hard capsule shell in this other than this method, there are different methods like hand operated gelatin capsule filling machine consists of a following part. The previous hand operated machine has maybe consists of a bag with 200 to 300 holes. Means that particular machine have a holes, and the ranges of this hole is 200 to 300 holes. Holes are present at this particular machine or hand operated machine. And a capsule loading tray is also present, and a powder filling tray. Means first is capsule loading tray, in which you load your capsule or put or set your capsule on that tray, and after that you fill the powder on that capsule with the help of filling technique or on that tray. It's first to put the capsule on this tray. It's the tray, and you are putting this capsule, then fill your capsule on this capsule body part with the help of some techniques or with the help of a pouring, filling of the tray, and pin plate having 200 to 300 holes corresponding to the number of holes in the bag and cap holding the tray. Means there are 200 to 300 holes present in one tray, and these hold the capsule, and you fill the formulation to this capsule or to the hole, and this tray contain at least 2 to 300 capsules. After filling, close the cap, or cap is applied to the body part to closing that capsule. Next is lever handle is also present, and cam handle is also present on this tray or this machine for handling purpose or easily removing or filling of the capsule. This is a filling hard capsule shell machine. This is an automatic machine, and previous in this hand operated machine, you fill the capsule with the help of hand or with the help of in a small scale or lab scale. But this is a large scale machine that is used in industry, and the speed of filling of the capsule is very high in this machine compared to hand operated machine. So this is a machine for industrial use for filling of hard gelatin capsule. Next is filling of hard gelatin capsule. Capsule shell in the process of working. In this first process is rectification, and the second is separating the cap from the empty capsule. Means first to rectify your capsule part or capsule body or cap. After rectification, there's a separation of the cap takes place, or you separate the cap from the body parts or empty capsule. And when you separate body and capsule parts, so it easily remove two parts or convert into two parts. And after this, filling is easy for the web purpose. Next, filling the bodies and scrapping the excess powder. Means first to rectify your capsule. After rectifying, you remove cap and body part for filling purpose, and after that you fill your formulation, your drug in the body part of hard gelatin capsule. And if there's excess amount of formulation is present in the body part, then you scrap out or remove this excessive powder by the cell or that body part. And after removing this excessive amount or scrapping of excessive amount, to replace this body with cap or fit the cap part onto the body. And after fitting this cap part, your capsule get formed or seal of the capsule takes place. And this is a step-by-step procedure. And after sealing, there may be chances that some particle or some material are present outside the capsule. Then you clean the outside of the capsule or filled capsule. Then after complete procedure, after filling, you scrap out or clean the outer surface of your capsule. And there's a 1 lakh to 60,000 capsule per hour shift in this machine. Means it forms very large quantity of large amount of capsule, that is approximately 1 lakh 60,000 in a 8-hour shift is formed in this filling machine. So this procedure, when we see the overview, start by first to rectify, then remove the cap and body part, then seal the material into the body part and do this empty capsule. And then after filling the material, you scrap out of the excessive material if it's present in more amount. And after then you fit the cap into the body parts, and closing of that body parts takes place. If there's excessive material or some powder material present outside that capsule, then you clean the capsule final stage. And after this, the capsule is ready for your final product or final dosage form for coming in a market. So this is regarding the filling of hard capsule or procedure, how you fill your hard gelatin capsule. This we see these steps one by one. In first step, that is rectification. The empty capsules are oriented so that all point in the same direction, that is body and downward. Means before starting the procedure, you put all capsule in a proper way or in a uniform way in the same direction. That you put your capsule downside or body part is on downward or downside, and after putting this all capsule in the same direction, in general, capsule pass at the one time to the channel just while enough to grip at the cap end. Once you put like this, that it's easily to put your cap or fit your cap. Grip is maintained between cap and body part. And in this capsule will always be aligned body downward, and the regards of which end entered in the channel first with the help of a specially designed blades. Means rectification is very important of first step in this all processes depend on this step, because if you don't put your capsule body proper way, then the chances that some filling problem is occur or your cap body is not fit with your cap. So first you can put all the capsule body parts in this tray, and after putting this you should have some see that all in the same direction. This body should be in a downward direction. After filling this, you put the sample, or after filling that, you can check that there's proper grip between the body parts with the tray or in aligned line, and then fill the downwards to enter the compound or your drug in the channel first. And there's been some blades which help to proper filling. So this rectification is the first step. After rectification, second is separation of cap from the body. Hence, first you put your capsule on the tray, and you should make sure that all are in the same direction or same line, and all capsule are in the downward and body parts is on the downside. Next is separation of the cap from the body. In this, you separate out the cap from this capsule. After setting this capsule, remove cap part of all the capsule, and rectified capsule are delivered body and first into the upper portion of split brushing or split finishing, which is a process after rectification or how we remove. That's a maybe portion of a splitting upper part or cap part, while split brushing or split filling of the ring part or upper part. Next is vacuum applied from below pulls the body down into the lower portion of the split brushing. Means you apply vacuum or some pressure with the help of a vacuum or application of this vacuum, body pulls down, and your lower portion pulls down or split out from the cap parts, and diameter of the bush is too large to allow them to flow the body, follow the body, and split bushing are separate to explain the body for the filling. Means after the rectification, you apply some pressure or some vacuum onto the capsule, and these capsules are due to this vacuum remove the upper parts of cap part, or you can easily feel because it's separated out, allowed to separate the body or cap part. And after this exposure, you can easily fill the material on this capsule or body. The filling is takes place by splitting or splitting of the capsule and body parts. Next step is filling. Means first is rectification, second is separating of cap and body parts, third is a filling. In this, you fill formulation with tablet, not tablet, powder, granules or beads in the capsule or body part of gelatin capsule. So there's some machines are used or some filling techniques are used for filling this. Our fill principle mainly used for filling of the formulation into this hard gelatin capsule. Because of auger mounted in hopper rotate at a constant speed rate. It's a one mounted auger or hopper which is rotated in a constant speed or constant rate, and rate of delivery of powder to capsule tends to the constant. Means you can say that this auger principle mainly used for filling of a hard gelatin capsule, and it's a one instrument that is put on the capsule formulation, and these auger is rotate continuously or uniform to all your capsule or that particular tray. Due to this uniform rotation or continuous rotation, the capsule gets filled with the help of this auger rotated or auger mounted hopper rotation, and constant rate is filled to the capsule body or powder of capsule takes place in a capsule or in the body parts. So this is the filling. This filling vibrative fill principle. And not only auger principle is used for filling, there's also some different procedure or filling principle you can also use for this filling purpose. And in this, or after this auger principle, there's a vibratory fill principle is also available. And in this vibratory fill principle, in a powder, a perforated resin plate is positioned and connected to vibrator. Name itself say that I use one vibrator for this filling purpose or for filling of a powder into capsule. So you put your powder or a formulation to this perforated resin plate, and after this it rotate continuously or with the help of vibrator. Your capsule gets filled with your powder or with the help of this connector. Next is a powder blend tends to be fluidized by evaporation of the plate and assists the powder to flow into the bodies, the hole in the resin plate. Means due to this powder plate or this fluidized evaporator, powder can fill in the body part of the capsule and holes of the this hard gelatin capsule. So in filling part, we see the two principle. One is auger principle. In auger principle, you fill with the help of auger rotator. And next is vibrator. And due to this vibrator, you can easily fill the capsule into hard gelatin body. And you put a powder sample into this capsule shell. And there is a continuous uniform filling which takes place with the help of this vibrator. After vibrator, there is a third technique, that is piston tap principle. In this piston tap principle is a piston or tamping pen, means one piston like equipment or one tamping pen is there for this filling, and lightly compress the individual doses of the powder into the plug. Means some powder or some dosage is put over the help of this piston or this pen into the plug is called a slug, and eject the plug into empty capsule bodies. After filling this material or this formulation into this body or capsule body, then you easily eject the capsule or eject the plug into the empty capsule body. So this is the third procedure. First we see the auger principle, second is vibrate, third is the piston tap principle. These are the techniques for filling for capsule or hard gelatin body part. After filling, next step is cleaning and polishing. In this, a small amount of powder may add. Before this cleaning and polishing, you remove the excessive material if present to the body part. Or you can see that there's a large amount of it is present in the capsule or overfilled capsule. Then you can also remove the excessive part of this capsule or scrap out this excessive material. Then there's one next step, that is cleaning and polishing, which takes place for this capsule. In this, a smaller amount of a powder may adhere outside of the capsule after filling. There may be chances that because there's a large number of the capsule and this process is continuous process, and some material maybe goes outside your capsule or outside surface of your capsule after filling. So if this problem is occur or some material present outside your capsule, then you use some removing procedure or polishing of capsule which takes place. In this, maybe pan polishing or cloth polishing or brushing which takes place. In pan polishing, you put your capsule or with the help of pan, you remove excessive material, clean the capsule. In cloth polishing, with the help of cloth, you manually remove the excessive material, clean your capsule, and brushing, there's one brush that you use for cleaning purpose or cleaning of your material or excessive material on the surface of the capsule. Now, filling possibilities. By using hard gelatin capsule, a variety of materials can be filled like powder, granules, pellets, liquid, semi-solid, and tablets. Means for this hard gelatin capsule, you don't feel only granules as well as powder, but variety number of a formulation or variety of a drug you feel in the hard gelatin capsule, or there are different possibilities. And in possibility, you can say that you can feel different formulation. In this formulation, maybe use powder or powder drug formulation or granule formulation. And so if your drug is in a granule form, next is pellets form, or liquid or semi-solid tablets also. Means this hard gelatin capsule is not only limited for solid dosage, but you can also use for semi-solid and liquid type of formulation. But make sure that these formulation don't affect your hard gelatin capsule shell or don't degrade, or there may be chances that it will get convert into more flexible form. So first to assure or check the compatibility with your capsule cell, and after this you can use this capsule for filling of any type of formulation, including solid, liquid, or semi-solid. In solid, you used maybe powder form, or granules form, or pellets form, or maybe tablets form, or filling of your hard gelatin capsule. So these are the filling possibility. This is a one diagram that contain different type of formulation, or hard gelatin capsule contain different formulation. In first, we fill powder or granules. So mainly small in size, maybe a powder form or maybe small granules that is filled in a hard gelatin capsule in body parts, and then apply the cap part and close the capsule. And second is pellets. It's just a little bit smaller by this granular powder part. And after filling the granules in the capsule, you again close the cap and the capsule is ready. Next is paste. You can see this is a semi-solid form, or in a maybe thick form that you put in your hard gelatin capsule cell in a paste form. And after putting this required amount of a paste or filling of this capsule, you put this cap part or close with this capsule body with the help of the cap. Next is capsule. In this, you put your capsule, and if this capsule is not sufficient, then you can also use some excipients that don't show any effect, or maybe granules or powder, or maybe you also use only capsule. So this is a capsule containing the hard gelatin shell, or you use a hard capsule, or to put capsule into this hard gelatin body shell, and then apply the cap and close the capsule. Next is for tablet. In this, instead of a capsule, you add or put a capsule into the hard gelatin shell body part, and then close with the help of a cap. So this is a type or different formulation that you use for filling of your capsule or hard gelatin capsule cell. And you can also use some semi-soluble liquid formulation instead of this, but you should assure check the compatibility with your capsule shell. So this is a structure or diagrammatic representation of different formulation that you feel in your hard gelatin capsule. Next is evaluation parameter, how we evaluate this hard gelatin capsule. So almost some parameters are similar to a tablet evaluation parameter. Just a little bit changes of evaluation takes place. And we can discuss different major parameter of this evaluation of a capsule. Not all evaluation, because some are just similar to a tablet. In this first parameter is disintegration test. Second is dissolution test. Third is content uniformity and weight variation test. These four tests we check or evaluate for hard gelatin capsule. Now we discuss this one by one. According to BP, method for disintegration of the capsule means how you calculate or how check the disintegration time of the capsule according to BP, or specific procedure that is given in British Pharmacopoeia. According to BP, introduce one capsule into each tube, suspended the apparatus in a beaker containing 600 ml at 37 degrees Celsius temperature. If you see the structure or diagram of apparatus, or you know the machine of this disintegration apparatus, then you easily understand this disintegration test. There's a one test tube like equipment or container, and capacity is of that beaker or that container is 600 ml. Means if fill a buffer solution or maybe water solution or any solvent up to 600 ml or at least 600 ml, and then with different test tube like container, or this test tube is maybe 4, 6, or 3, and you put your tablet in this test tube like container and maintain the temperature of your buffer solution, water solution is 37 degrees Celsius according to body condition, body requirement. And these tube are in a suspended condition, and you put your capsule in the test tube or in a tube, and if hard capsule flows on the surface of the water, the dices may be added. Means one beaker, and you fill your buffer solution in this beaker up to 600 ml, and in this beaker there's a tube or test tube like container, and you put your tablet in this tube, and if you not tablet, you put your capsule in this tube, and after putting this capsule in this tube, You can see like it's a float condition or in a suspendable stable condition. If it's a floating condition, your tablet float on the surface, then you apply one disc or put the disc, because the disc is also available for this dissolution test. If your formulation is get float, then you add this disc. Otherwise, it's not needed. If a formulation in a suspended condition or get settled down, you use this only in floating condition. Then operate the apparatus for 30 minutes and remove the assembly from the liquid. After continuing this procedure or operating this apparatus for 30 minutes, you remove the liquid, not remove the liquid, remove the assembly and check how much capsule is disintegrate. And the capsule pass the test if no residue remain on the screen of the apparatus, or if residue is remaining, it consists of fragment of the shell. Means after 30 minutes after performing this test, you should check or assure that there's no residue or no material is present in this disintegration test. All completely capsule get disintegrate, or if there's a residue, then you can see that this residue is maybe your shell or fragment of your shell. So if there's no residue, then your test will pass, otherwise it fails for this disintegration test. Now we see the conclusion regarding summary of this test. Means first you put your capsule in the tube or test tube like structure that is present in the disintegration apparatus, and fill this disintegration apparatus buffer solution up to 600 ml. Then maintain the temperature up to 37 degrees Celsius for your formulation. And after this, you put your capsule onto this tube, and if your tablets capsule see that in a float condition, then you put that as to prevent from this floating condition. And after 30 minutes, or you continue this procedure, or rotation just takes place for not rotation but up and down process takes place in the simulation for 30 minutes. And after 30 minutes, after completing this procedure, you stop your disintegrating apparatus and check how much material get disintegrated out from your solution or from capsule, and check if there's any residues present or not. If no residue or no material is present in this disintegration after 30 minutes, then your test will pass. If some residue is present, then maybe your test is failed. And if residue is present, then maybe your fragment shell or hard gelatin shell. If it's a fragment shell and hard gelatin shell, then no problem, but your formulation should completely disintegrate. It should don't have contain any material for passing the test. So this is regarding the current test or disintegration test according to PT. Next is weight variation test for hard as well as soft gelatin capsule. This test is same for both hard as well as soft gelatin capsule. In this, you just check your tablet or complete batch should have a uniform weight. Suppose you are preparing 1 gram or 500 mg capsule, then your complete batch should have that amount of weight, or don't vary too much. There's a little amount of variation is accepted, but more variation show error, or you can reject your batch completely. In this, suppose you are preparing 50,000 capsule in one batch and the weight is 500 mg, then you make sure that all 50,000 capsule have a 500 mg weight or maybe accepted range. Otherwise, you can reject your batch. So in weight variation test for both hard as well as soft gelatin capsule, in this first you weigh or take the 20 capsule or individually weigh. Average weight and percentage deviation from the average weight is determined. Means randomly you take 20 tablets from your batch on that particular batch, and after taking this 20 capsules, after taking this 20 capsules or randomly taking this 20 capsules from that particular batch, you weigh the capsule or weigh the individual capsule. After weighing this 20 capsule individually, you calculate the average weight or mean weight of this 20 capsule. You know that how we calculate the average segments of 20 capsule weight divided by 20, because you are taking 20 capsule, and after calculating this average or mean weight, weigh variation will become average plus minus 10%. Means average weight is observed within the range, or according to required range, or 10% plus minus variation is a limit or in an average acceptance criteria, then no problem. And if the variation is beyond the limit, means more than 10%. at least 10% or up to 10% are considered, plus minus 10% are considered in the wet variation test. But if then beyond the condition or more than this 10%, then it may be show some problem or reject the test, and net weight of the content are determined. Then each and every capsule is determined the net weight, and net weight of the more than 2 capsules should be fall outside the average net weight, that is 10% value, and net weight of the no capsule should be outside the average net weight of 25% limit. If your test is beyond the limit, then you individually weigh each and every capsule, and individual capsule not more than, or consider at least 2 capsules we consider. If it's beyond the limit or more than 10% limit, then you can accept your test. And if some more than 2 capsules have beyond the limit, then you reject your batch, or you can say that average weight of your complete batch is 25% plus minus you consider, or in the limit you consider. If it's more than 25%, then there's no chances to reject your complete batch. Next is a net weight of a 2 to 6 capsule. Divide from 10% or 10 to 25% plus minus. And the net weight of a 40 more capsule determined out of the 60 capsule tested. The net weight of the more than 6 capsules should be divided from average weight of 10 to 25%, and none of them from 25%. Means if this test is failed, then you can also perform another test, and in next time you take 40 capsules, and total there is 60 capsules are present, because we are previously taking 20 capsules, and in the next test we are taking additional 40 capsules. 60 capsules are present in this test, and you perform this test on 60 capsules, and after this 60 capsules you can check individual weight of each and every capsule or all 60 capsules. And in this, not more than 6 capsules, or at least 6 capsules are in accepted range plus minus 10%. And if it's more than 6 capsules, then you can reject your batch, or overall average weight of all 60 capsules should be accepted in plus minus 25%. So this is the acceptance criteria. Means first to perform this test on 20 capsule, and the 20 capsule and in a limited range, that is plus minus 10% should be accepted, or 2 capsule in a maybe limit, not that limit or not the limit. If more than 10, then you again perform more than 2, then you again perform this test on additional 40 capsule. This total is there 60 capsule, and on out of this 60 capsule, there's a 6 capsule you can take if it's beyond the limit. If it's more than 6, then you can reject your test, or overall is 25% plus minus is accepted, or 2 capsule, not 2, that is 6 capsule is overall 10% plus minus accepted. If it's not an appropriate, then you reject your batch. And these 6 capsule net weight of 6 capsules should be derived from average net weight, that is 10 to 25%, and not of more than 25%. If limit is plus minus 10%, then average weight is less than 300 mg, and 7.5% is when average weight is 300 mg or more. This is also some specific condition according to net weight of your capsule or your formulation. Suppose your capsule net weight is less than 300 mg. So in this less than 300 mg, you can select the variation is 10% or plus minus 10%. If it's 300 mg or more than 300 mg, then in this condition the percent will maybe change or vary. It reduce up to 7.5% plus minus. So this is regarding the weight variation test. This is a percentage deviation according to the average weight of the capsule. If less than 300 mg, then 10% deviation is considered. If 300 mg or more than 300 mg, then percent deviation is 7.5 to consider, or at least 7.5. If this limit is exceed or more than this percent, then your batch is not a good quality. You reject your batch. For acceptance criteria, you should have this limited deviation is we consider. And according to this deviation, there's a limitation for according to dose. Less than 300 mg is only 10%, and 300 to more than 300 mg is 7.5% deviation we consider. Next is dissolution test for the capsule. Dissolution test for the capsule is almost similar to a tablet. Instead of a tablet, you will put in a capsule, and some readings may be changed due to the shell containing. In dissolution test capsule, apparatus dissolution media and test is seen that uncoated and plain coated tablet means those tablets who are uncoated or plain coated tablet. There's similar procedure for a capsule also. You perform these procedures same as uncoated and plain tablet, coated tablet. And next is uniformity of drug content. Uniformity of drug content means how much drug present in your capsule, or all capsules should have a uniform drug. Suppose you are adding 200 mg in dose of capsule, then you make sure that your complete batch have a 200 mg drug, or at least 200 mg. There is little amount of variation of plus minus may be considered, but it should not exceed that limit. So in this you check how much drug content or active ingredient are present in particular capsule or each and every capsule. In this, a sample of 30 capsules is taken and 10 are assayed individually. Means first you take 30 capsules instead of a 20 capsule. In this test, you take 30 capsules, and out of this 30 capsules, you randomly take 10 capsules and assay these 10 capsules. With the help of these assay procedure, or assay is mainly used to check how much drug present in your formulation or in your capsule. So first you take 30 capsules, and out of this 30 capsules, you randomly assay the 10 capsules and perform the assay on these 10 capsules. And next is the drug content of a capsule should be within the limit. Means it do not exceed the limit, or it should be within the limit of average net content, that is plus minus 15%. And drug content of none of the capsules fall outside average from the net content, that is 25 plus minus %. Means after performing this assay on 10 capsule, then you can say that it should be within the limit of plus minus 15% is considered, and for overall 30 capsules it should be plus minus 25% we consider, and it should be within the limit. If 1 to 3 capsules fall outside the average limit, that is 15% plus minus. The remaining 20 capsules are assayed, and drug content of at least 27 out of 30 assay should be within the average drug content, that is 15% of the limit. Means first you take 30 capsules and perform the assay procedure on 10 capsules, and out of this 10 capsules, your 3 capsules should be within the limit, that is plus not 3, at least 7 capsules within the limit, or up to 3 capsules is considered if it's not in the range, plus minus 15%. And if it's more than 3, then you again perform remaining 20 capsule assay, means total 30 capsule assay you perform. And after performing assay on this 30 capsule, you check the variation. If out of this 30 capsules, 1 to 3 capsules beyond the limit, then you can accept your batch, or if it's more than 3 capsules beyond the limit, or don't have a limited acceptance condition, because at least 27 capsules are required in acceptance condition. 3 capsules you can consider this batch is passed, and each capsule have plus minus 15% weight variation in the limit, and none of the capsules fall outside the average drug content, that is 25% plus minus limit. Means 15 is acceptance criteria, and remaining should not fall the 25 plus minus % limit. The test is prescribed for the capsule when active ingredient is less than 10 mg or 10 plus field weight. This is also have a specific condition for according to dose. It's your tablet, but your capsule contain less than 10 mg or up to 10 mg, or you can say 10% weight of your average weight or field weight of your capsule. Then this is the condition or acceptance condition for the capsule. In case of less than 10 mg or 10% of the field weight. And there's a special quality test for soft gelatin capsule. Some specific test or other test is required for soft gelatin capsule. This test is not for hard gelatin capsule. And soft gelatin specific test for the seal thickness. This measure under a microscope, means outer thickness or soft gelatin thickness to check in soft gelatin capsule. With the help of a microscope, and seal thickness is also observed. Next is total or cell moisture test. There is some moisture present in the soft gelatin capsule because they are soft in nature, and how much moisture is present on this cell. and you check it's an acceptance condition or not, because that much moisture may show some problem like bacterial growth or microbial growth, or if it's in less amount, then it will don't show proper capsule or soft gelatin capsule, it can dry. So you can check total of how much moisture is present at your soft gelatin shell. In this, moisture content will determine the particular temperature and humidity condition. Means you expose your soft gelatin capsule in particular environmental condition or in environmental changes condition. You change your temperature and humidity condition and observe that how the changes of moisture takes place or any of the moisture takes place. Next is capsule fragility and rupture test, means how much fragile the test or rupture property, how to easily rupture. Check with the help of some equipment in the soft gelatin capsule. Next is determination of freezing and high temperature effect. If you are storing your soft gelatin capsule or your formulation in different temperature of freezing or high temperature condition, then what is the effect? You check by the help of this test. In this, more than 45 degrees Celsius for 30 days more, and these perform similarly to shell integrity test also. Next is physical stability of the capsule. This is the stability of the formulation or proper condition of your capsule. In this, how much it is stable for storage condition or during storage. In this, for conducting this test, sample of the capsule are exposed to the following condition over a period of 2 weeks with periodic observation. Means you put your sample in specified normal condition or exposed in some another condition for 2 weeks or at least 14 to 15 days period of a time. And during this period, you observe your formulation or continuous observation takes place. And these are the conditions which is required for this physical stability test of the capsule. In this, first is 80% relative humidity or RS as room temperature in the open container. Means if you are putting a capsule in a room condition or in an open container, then you require 80% relative humidity. And if you put your capsule in an open container, then there's a 40% humidity is required, 40 degrees Celsius is required. And if you put in a closed container glass, what is a tight screw, means there's no chances that will be air or any moisture content in this to put your capsule in 40 degrees Celsius. These are some conditions for checking physical stability. Both glass and substance difficult to perceive effect of above storage condition on the capsule shall are noted and recorded. In the specific time period, to check whether the changes of takes place or not, or your capsule should be in a stable form or not. These readings are recorded for physical stability test. After completing this topic, you should know about this learning outcomes. In this brief introduction about the filling of a hard gelatin capsule, how the filling takes place, we already covered different filling techniques. Means first is rectification, then after rectification, removing of a cap and body part, then filling of drug formulation, then scrapping out of excessive material. After scrapping, cleaning and polishing takes place, then closing. Or you fit your cap into body part. This is some steps and different filling machine or different technique already covered is used for filling of a capsule. Next is filling and finishing, a special technique for formulation of hard gelatin capsule. How this finishing takes place, and including evaluation parameter, different evaluation parameters for this hard gelatin capsule and some for soft gelatin capsule. So this is the learning outcome. After completing this topic, we should know about complete information regarding that list hard gelatin capsule, including starting from introduction to evaluation parameter, because in previous lecture we already covered major part of hard gelatin capsule, including introduction, time, size, shape, excipients, formulation. And today we continue the remaining parameters like filling, finishing, and how you evaluate. So you should know after this lecture complete knowledge of hard gelatin capsule and some evaluation tests on this capsule, some for soft gelatin capsule. So this is the learning outcome. Next is in reference part. These are some reference and some pharmaceutical dosage from drug delivery system. 8th edition by OSV and Alan Nicholas, G. Popovich, Howard, C. Ansel, published by VI Publication PPT. Next reference is textbook of physical pharmaceutics by CBC Subramanian, published by Rectification. Next, third reference is the theory and practice of industrial pharmacy by Leon and Blackman, Haberts, Elibam, and Joseph LP, third edition, published by Diversity Publishing House. Next reference is Martin Physical Pharmacy, Pharmaceutical Science, 5th edition by Patrick J. Singh, published by Liverpool William and Beckley. These are all good references. After this, there's a question part related to this capsule topic. In capsule, Rotafill is used to fill in A option bottle, B is parrot, C is liquid, L is corrosive liquid. And next, second question, gelatin and glycerin are used for preparation of lemon and specified ratio. Identify the correct ratio. 1:1, 5:1, 9:1, and 10:1. These are the four ratio for gelatin and glycerin. Select and correct ratio. Next, third question is capsule shell are made of with ethyl cellulose. C. The option is sugar. C is gelatin, and D shellac. These are the four options for manufacturing of the capsule shell. And next fourth question is the vegetable capsule shell are prepared with. E option is gelatin. B option is chitosan. C option is HPM cellulose with cellulose. And D is none of the mentioned. So this is the fourth question. Next and fifth question, gelatin is a option A is fat, B is protein, C is carbohydrate, and this none of the mentioned. In this four option, you can select any one correct option for gelatin. Next in sixth question, hard long strength gelatin used to manufacturing of A soft gelatin capsule. B is a hard gelatin capsule. D is a both soft and hard gelatin capsule, and D is a none of the mentioned. Next and seventh question, capsule are there's a four option. A is a unit solid dosage form. B is a solid dosage form. C is compatible with liquid filling, and these are all of the mentioned. According to this four option, you can select any one correct option. Maybe all parameter A, B, C are correct, or maybe out of the same one is option is correct. So you select which appropriate for your capsule formulation. And next question, eighth question, capsule cell can be made from A is gelatin, B is PVA, C is gelatin. These all mentioned means all ABC options are correct. In this, you select which one is correct for regarding the capsule cell or which material used for manufacturing or formation of capsule cell. Next and ninth question, the points of interest for development of successful capsule dosage form are A option is physical and chemical stability, B is a fill composition, C is shell material, and is all mentioned. And in last or 10th question, in process tests are done for capsule, and this A option is to reduce the cost. B is the consumer acceptance. C is to minimize the risk of product failure, and this none of the mentioned. Out of this four ABCD option, you can select any one correct option which is required for in-process test of the capsule or which is appropriate for in-process test of the capsule. So this is regarding the question part of the hard gelatin capsule or introduction part of the capsule. After completing this topic, you can easily answer the question if you understand this topic completely. So this is all regarding the question part. So thank you so much for watching and listening this video. Thank you.